Good morning, friends. We'll start chapter 10, Magnetization by means of electric current. It's mainly units. It's sometimes called field intensity and magnetic field density. In terms of magnetic field, often used by both depending on situation. The magnetic field strength H is called field intensity and the magnetic flux density B. Magnetic field is often used for H or B for both depending on the situation. The quantity B is constantly used for magnetic flux density, whereas H is the magnetic field strength. Don't use all this. SI unit of magnetic testing. Magnetic testing units are mainly magnetism, visible light, and ultraviolet radiation. SI unit include Weber and Tesla and several derived units. Magnetic field intensity, the ampere per meter replaces Oersted OE. Magnetic field intensity. Magnetic field strength is expressed as amperes per meter. 1 ampere per meter is equal to 1 by 80 of an Oersted. Relationship is something like this. Magnetic flux density is Tesla replaced the Gauss. 1 Tesla is 10 to the power 4 Gauss, means 10 to the power 4 lines of force per square meter. Is called 1 Tesla. That is the Weber per meter square. So only flux is Weber. SI unit Weber, Tesla. Here it is Gauss. Field intensity ampere per meter or Oersted. 1 Oersted equal to 79.577 ampere per meter. So 1 Gauss equal to 10 to the power minus 4 Tesla, 0.1 millitesla. So this is sometimes they ask the Weber replaces Maxwell. Magnetic flux. Weber per meter square is Tesla. They call it Maxwell. So 1 Weber is 100 max. 1 Maxwell is 10 to the power minus 8 Weber. 1 Weber is 10 to the power 100 millimax. Illumination lux. 1 foot candle is about 10 lux. 10.67, something like that. Ultraviolet radiation. Microwatt per centimeter square. So we are looking for 1000 microwatt per centimeter square. So that is required for irradiance. Sorry, 1 minute. Give me 1 minute, please. Is it okay? So diamagnetic, paramagnetic, and ferromagnetic. The types of magnetic materials. So now it is clearly, you can see here. Diamagnetic refers to the magnetic permeability slightly less than that of a vacuum. These are all questions. Induced magnetism is in direction opposite to that of iron. Diamagnetic material include mercury, gold, bismuth, and zinc. So diamagnetic is permeability slightly less than vacuum. So it is opposite to that of iron. Diamagnetic slightly repels. Paramagnetic denotes a substance with permeability slightly greater than that of air. A slight alignment of electron spin in the direction of magnetic flux flow. Such materials are placed in strong magnetic field. There is a slight alignment. This alignment exists only as long as paramagnetic material is in the external magnetic field. Aluminum, platinum, copper are the paramagnetic material. Ferromagnetic are iron, cobalt, nickel. Ferromagnetic materials have permeability greater than that of air when placed in an external magnetic field. It is just to denote a substance with permeability slightly greater than that of air. The magnetic domains align parallel to the external field and remain aligned for some period of time after removal of field. This continued alignment after removal from the external field is called retentivity. Electric current pass through the straight conductor wire bar, for example, create a circumferential magnetic field around that conductor. By right-hand rule, circular magnetization test object through which magnetic electric current pass. Circular magnetization of solid test object using direct or indirect contact methods. The prod method also circular. In use, wet magnetic particles are not normally used in the prod technique because of electrical and fire hazards. Care should be taken to maintain clean prod tips, minimize heating the point of contact, and prevent prod arc strike, local heating the test object. With prods or pads, aluminum or copper braided tip rather than solid copper tips are recommended because of possibility of copper penetration if arcing occurs. Figure 2 shows the direct contact method for producing circular fields in a ring to indicate circumferential cracks. To achieve a reliable test of the entire cylindrical surface, two magnetization are required. The ring must be therefore be turned 90 degrees and then retested. Figure 3 shows a current flowing circumferentially around the ring, which can be induced by making the ring a single turn short-circuited secondary transformer. The total current induced in direct contact method of magnetizing ring shaped object to locate circumferential discontinuities. You have to rotate 90 degree. Induced current method of magnetic ring shaped object to locate circumferential discontinuities. Induced current path circumferential discontinuity. induced by coil and there is laminated core. The ring is greatly increased by inserting a laminated core of ferromagnetic material through the ring. Circular magnetization of hollow test object. Central conductor method. Longitudinal magnetization. Coil magnetization, field flow magnetization, and yoke magnetization. So coil magnetization, important consideration, coil magnetization. Circular shape radial discontinuities will indicate only the white area to reveal radial discontinuities. And then you move 90 degree. The black area is not. The test object must be rotated 90 degree and remagnetized. Circumferential discontinuities will be indicated on the shaded area. We will circumferential discontinuity the whole area. The 90 degree 2 times testing, that's all. The radial discontinuities in the shaded area it is necessary to rotate the test object 90 degree and remagnetize it, although the technique is not recommended. Internal conductor method used to produce circular magnetization. Several ring shaped test objects magnetized simultaneously. Cross close-up of ring of cracks in several locations and orientation. Circular magnetization. You find long for circular magnets. You will find longitudinal defects, and for longitudinal you find radial defects. Field flow magnetization. Power requirement limit to effective length is to about 4 foot, 1.3 meter. However, special technique using direct or induced longitudinal magnetization in one step for lengths more than 10 foot 3 meter. So moving a magnetizing coil several times may impractical, time-consuming test object with length to diameter ratio less than 3:1 require no special handling. A consistent field wholly contained within the test object may be required. Yoke magnetization. Such yokes are often specified by their lifting power or tangential field strength. They may give in pounds. Just check for pounds. That's the yoke break test has been devised to help evaluate the effect of coating type and thickness on the introduction of the flux to a ferromagnetic substrate. The test uses a dynamometer to pull or break an energized yoke from a bare test plate. Its test is performed using a STM-A36 steel plate 1018 steel plate as substrate. 4 separate coating types were revealed, evaluated, indicating organic zinc, zinc chromate, enamel, and phenolic epoxy. So you can see coating thickness milli-inch. Decrease in pool with increase with coating thickness. Yoke produces pool of 8.7 kg on the bare test plate. Yoke centered to pole spacing maintain 4.25. But there is some minimum things are there, so you have to follow 4 4.5 kg for a C yoke and into 4 18 kgs for a DC yoke. with largest 8-inch spacing. The difference may be the result of concurrent leakage fields that exist in the multiple bead weld cap but not the single bead weld as shown. So if single bead there is no gap, multiple bead then there is a problem. Discontinuity if there only. But here you get many things. So you have to find out what is the where the difference, and that is slightly important for to first be circularly magnetized and examined for indication. So this is important. So in testing need both, and first circular magnetization, then longitudinal magnetize, because to higher, so it will just change, it will be easier. Otherwise you have to demagnetize. Demagnetization is the final step. But in between you don't need demagnetization. Because that will demagnetize itself. And longitudinally change. That is called demagnetize. It will change to longitudinal. Rods, it is recommended that a magnetizing current of 90 to 110 ampere for each 25 mm prod spacing. These are all questions and answers, so you have to remember. There is no other way out. 90 to 110 for each 25 mm of prod spacing. They will give some prod spacing, then you have to find out. Use for metal, use less than 0.75 inch thick. So magnetizing current of 100 to 125 for 1 inch thick prod spacing is recommended for material 0.75 inch or more in thickness. So there are two things you have to remember. Prod spacing less than 3 inch 80 mm is usually not practical because the particles tend to band around the prods, making interpretation difficult. So you will find many things there. So everything will be submerged. Yokes. Field strength of the yoke of a permanent magnet can be empirically determined by measuring the lifting power. A Hall effect probe is used. It should be placed on the surface midway between the poles. Coil. Cylindrically shaped test object, the diameter of which do not exceed about 1/10 that of the coil, and the test object length to diameter ratio doesn't exceed 15. Long test object having length to diameter ratio greater than 15 require more than one test along their length. In this case, the most effective longitudinal field in the test object is only extend about 9 inch on each side of the coil. Amperage produced in cylindrically shaped selected test object is a flux density of about 70,000 lines in inch, 1.085 Tesla. Fill factor of coil. So in the case of fill factor coils, the cross-section area of the fixed encircling coil greatly exceeds the cross-sectional area of test object, less than 10% of coil inside diameter. A proper test object magnetization, such test objects should be placed well within the coil and close to the inside wall of coil, as shown in the figure 10. With a low fill factor, adequate field strength of eccentrically position of test object With length of diameter ratio between 3 to 15 are calculated from the following equation. Ni equal to K divided by L by D plus minus 10%, or ampere turns is 45,000 divided by L by D plus 10 plus minus 10%. It is missing here. K is 45,000. L by D you find or given. Either L by D is given or L given D is given. So equation 2 should be used if the test object is low fill factor position in the center of the coil. This never happens. So this is just for a sake of looking. If somebody is asking, then still these things are there in the booklet. If you find, you can find these equations. You can search, but it will take your time, unnecessary time. Just remember this one first, and the second one you may. This one 43,000 into R divided by 6L by D minus 5 plus minus 10%. So it is used for low fill factor center. If you are putting at center, that is never used. And if this equation 4 should be used for high fill factor coils. So K Ni equal to N is number of turns, I is the current. So if N is given, you just divide N with I, or I given, you get N. So that's how we are doing. And here K is 35,000, L by D plus 2 plus minus 10% for high fill factor. That's all. These two for coil, you have to what? Mainly the first one. Second one is high fill factor. Generation of indication, interpretation of indication, evaluation of indication. So generation of indication. The magnetic particle testing indications are generally generated by appropriate magnetization, applying the appropriate magnetic particle. Okay. Then interpretation of indication. You find how surface indication, subsurface, false indication. The indication which is well defined is along with a sharp and noticeable buildup of particle, characteristic of particle tightly held to the surface by relatively strong magnetic field. Subsurface indications. Fuzzy indication caused by discontinuities below the surface that produce a accumulation of particle that are broad and fuzzy in appearance. The first step in interpretation is to decide the character of origin of the indication. Indication can broadly be categorized as false or true. False indications that are not caused by the magnetic flux field, the magnetic forces. These are generated by other means. For example, material construction, material obstruction, improper processing, data fingerprint. Other examples are particles held mechanically or by gravity in a shallow depression. Particles held by rust or scale in the surface. True indications that are caused by applications of the magnetic flux field or magnetic flux leakage. So there is false indication finish. There is relevant or non-relevant. False and true. So true is that is caused by the application of magnetic flux field or magnetic flux leakage. False means totally false. Then comes relevant indication, non-relevant indication. Indications produced by leakage fields that are result of actual discontinuities material under test. These indications are further subjected to evaluation based on acceptance criteria of the material as agreed upon by manufacturer and customer. Non-relevant indications. Indications produced by magnetic flux field as a result of geometry and or physical conditions but not by a discontinuity. Non-relevant indications can occur singly or in patterns as a result of magnetic flux leakage at sharp corners, change in sections such as keyways or drill holes, bimetallic welds, lines, thread roots. Although non-relevant indications are not subjected to rejection, such an indication could mask relevant discontinuities that might be critical for the product service life. Thus, non-relevant indications require careful interpretation. Proper testing technique reduce the occurrence of non-relevant indications. So non-relevant is many ways: keyways, drill holes, bimetallic welds, splines, thread roots. Still, there are so many things are there. It is. So non-relevant indications may occur as a result of following. So these are many things there. Longitudinal magnetization. Longitudinal magnetization by coil generate poles at the end of the test object. So when the material is tested with yoke, the poles attract magnetic powder. And these are non-relevant. Cold reworking. Cold working produce change in the size and shape of the test object that may result in changes in permeability. The boundary area change permeability may attract magnetic particle testing when the part is tested. When different materials welded together, like stainless steel to steel, you find the indication. Those are non-relevant indication. Hard or soft spots. Change in the hardness of test object are subject to change of permeability. When the material different hardness is tested, the boundaries where change in permeability takes place may produce an unrelevant indication. Abrupt change of section. When material with abrupt changes in thickness is magnetized, a change in the magnetic field takes place. Creates local poles due to magnetic field leakage or distortion. Then comes evaluation of indications. Now this is most important part. In case of defect, the material is to be reworked, repaired, or discarded. The extension dimension of the indication within the acceptance criteria material under test can be accepted because such discontinuities do not affect the quality of future service of life and the test object. If the extension of the indication exceeds the maximum permissible limit in the accepted criteria, the material is subjected to rejection. Several guidelines may help the inspector to evaluate an indication in accordance with agreed upon acceptance criteria. Surface discontinuity is more likely to be harmful than a discontinuity of same size and shape below the surface. Discontinuity surface or subsurface within the dimension perpendicular to the principal stress plane are more likely to be harmful than discontinuities of the same size, shape, and location lying parallel to the stress. And discontinuity in areas of high stress is to be considered more carefully than discontinuities of the same size and shape in areas of low stress. Discontinuities that are sharp, for example, grinding cracks or severe stress raises, compared with rounded discontinuities. Discontinuities close to keyways or fillets are more harmful than discontinuities of the same size and shape away from such location. Magnetic writing, particularly test object having smooth and machine surface to avoid their being rubbed together or against each other. Paramagnetic test object, other paramagnetic test objects. Magnetic particle indication produced on these areas are a type of false indication called magnetic writing. So demagnetize will remove the magnetic writing. If the indication reruns after demagnetizing and reprocessing, it is an indication of discontinuity at or near the surface. Okay, we'll stop here.